The next type of division we'd like to do is called synthetic division. We've been practicing long division. And synthetic division is quicker and easier to do, but it only applies in certain situations. And so I've shown 3 examples for which synthetic division applies and 3 examples for which synthetic division does not apply. Let's first look at the cases where synthetic division does apply. And we focus on the divisor. That's how we decide whether synthetic division applies. Of course, here x minus 3, here x plus 2, here x minus 1/2. And what each of these have in common is it's simply 1x minus or plus a number. Now, in the 3 examples for which synthetic division does not apply, let's see why the divisor is not applicable to this type of problem, synthetic division. Here we have a linear divisor. These are each linear divisors, meaning x to the first power is the largest power. Here we have a linear divisor, but the coefficient of x is 3 rather than the required 1 that we have in each of these. Of course, here we have a divisor, but it's not a linear divisor, it's a quadratic divisor, meaning the highest power of x is 2. And of course, here we have another quadratic divisor. So synthetic division does not apply if it is a linear divisor but not a coefficient of 1 on x, or if it's a quadratic or higher. That is, if it is not a linear divisor. Although this has a coefficient of 1, it's a quadratic divisor. Synthetic division does not apply. Let's kind of reiterate or re-emphasize this idea so that we know the cases for which synthetic division does and does not apply. As it says here, synthetic division divisors must be of the form x minus a. And that makes sense here, x minus 3, x minus 1/2. We might pause because this doesn't say x minus a number. But this, let's investigate a little bit further. It's clear in this example, let's put it here, it's clear in this example that we have a divisor that's of the form x minus a number. Here it's not so clear that it's x minus a number. Here it is clear that it's x minus a number. And the issue is that we can clearly decide that the a value in this example is 3. But the a value and the a value in this example is 1/2. That's what's being subtracted. We have to manufacture an a in this case to understand that x plus 2 is really the same as x minus -2. So although we don't see the minus sign here, we recognize that the a, the number we're subtracting from x, is a -2. Now, identifying a in synthetic division is a very important part of the problem. We're ready to look at example 4, our 4th division problem, and it happens to be a division problem that we did previously, but this time we're going to use synthetic division. Notice synthetic division does apply, and as I recall, here we go, as I recall, we had a quotient and remainder for this problem using long division previously. So I'm going to put that here so that we can remember what our result was and compare in a moment. Now, when we're doing synthetic division, we start the problem in a similar fashion, except we draw what looks like an upside down long division symbol. And in this portion we put the dividend, but not the entire dividend, only the coefficients of the dividend. And so we again need to make sure that our dividend is in decreasing powers of x. Everything's in good order. And so the coefficient of the x cubed term is 3. We write single 3. The coefficient of x squared is -11. We write down the -11. And as before, we run into the position of x to the first power. It does not exist. And so we understand its coefficient is 0, and that's an important 0 to include. And then finally, our constant term is -1, and so we write our constant term. Now, once again, the issue is that if we even had a missing constant term, we would put a 0 in that position. Now let's go back to this idea of our divisor being x minus 3. this position we put in what's called our synthetic divisor, and that's the A we just discussed a moment ago. And so it's important to recognize what the A value is. Our divisor is x minus a number, whether or not we see the number. And whatever number we're subtracting from x in our divisor is the number that we call our synthetic divisor. So it's this 3 that we put right here. Now, before we continue, we draw another horizontal line, leaving some space between the top 2 rows. And here's how we proceed. We start with this negative 3 this 3 coefficient, and we drop it all the way to the bottom to get ourselves started. We put that 3 right here. Now, every time we see a number down here, it gets multiplied with this synthetic divisor. So in this case, we'll say 3 times 3, of course, which is 9. And that result goes in the next column in the middle row. So we write that 9 here. 3 times 3 is 9. Now we take the number on top and add the number on bottom. Negative 11 plus 9, of course, is negative 2. We have a new number on bottom, so it gets multiplied with the synthetic divisor. 3 times negative 2 is negative 6. That goes in the next column in the middle row. Now we have a 0 and a negative 6 we add together. So we know what that result gives us, negative 6. We have a new number on bottom. We take the synthetic divisor 3, multiply with the negative 6, and that, of course, is negative 18. Now we have a negative 1 and a negative 18 that we add together, and we get negative 9, and we are finished with our division. We're ready to write or interpret our answer. And it's the bottom row that we interpret our answer from. Now notice the number we have here, the very last position in that bottom row, is the remainder that we had before, and that's always the case. This position will be the remainder of our division. Now, these other numbers in the bottom row, these numbers, if you compare them to the coefficients of our quotient. 3 is the coefficient of x squared, negative 2 is the coefficient of x, and negative 6 is the constant term. So these represent the coefficients of our quotient. And the quotient will always be 1 degree less than the dividend. So the quotient will be x squared, since our dividend was x cubed. And that applies only in synthetic division problems that we can ensure that. So as we get to this stage of our problem, whether we knew the answer in advance or not, we should be able to look at our result of the bottom row and decide what the coefficient is. Another way to think is the quotient. Another way to think about this is if this is the quotient, constant term, x to the first, x to the second. So we have 3x to the second minus 2x minus 6 as our quotient, and our remainder, of course, is the last position in that row. And of course the last position was 0. We would have a 0 remainder, but then in this case the last position is negative 19, and we pick that up here. Let's do one more example. That's example 5, where we can use synthetic division.